Question 4c is a familiar one that we should be aware of from the past. So what it's asking us to find is the minimum distance from this point CD to the origin. So really I just need to create a distance equation between 0, 0 and CD. So we need to express the point P in terms of one variable. So I've substituted C into the function to get so D is really the same as f of C, which is the function value there. So that's 2 minus 3 over C plus 2. And then converting back to x, because the calculator obviously works better in x. I mean, in this case, it doesn't really matter, but let's just do it that way anyway. So I'm going to do my distance equation, which we've done a couple of times throughout the paper. So because I'm subtracting from the origin, I don't really have to subtract anything because they're both 0, 0, the coordinates. So it's each coordinate being squared underneath the square root sign. So once I set up my distance equation, because I want a minimum, again, that refers to calculus, so you need to differentiate and set to 0 to solve for that value. So here it is here. There's my define. I solve. I find my two values. The appropriate value here is the root 3 minus 2 because that is a negative result. Root 3 is about 1.7-ish. Subtract 2, so that's a slightly negative result, which you can see matches up very nicely with that one there. So please be aware of the two options and the one that's the relevant one. So that's the root 3 minus 2. I then sub it back into my distance equation to find the minimum distance, so 2 root 2 minus 6. So this is, again, another process and another type of problem you really should be aware of. It's come up on paper one. It's come up quite a few times over the years. So please study this one well.